She's COVID already. All
right, here we go. So, we've been talking about regular equilibrium in terms of like concentrations and in terms of pressures for gases. Now we're going to be talking about something called solubility equilibrium. And when we were talking about different types of reactions and different concentrations, we were dealing with Kc. We were dealing with gases, we were dealing with Kp, and today we're going to start talking about something called Ksp. Okay? So what Ksp is the solubility product constant. So you remember when you were in chem and we brought out one of these charts and we told you what was soluble and what was insoluble?
Yes.
Okay. And we just had like an S or an N on there.
Yep.
And if it was an N, it was insoluble.
Yep.
Well, there are degrees of insolubility. That's hard to say. And that's what our Ksp can tell us about. Okay? It's kind of the degree of something being insoluble. So when we called something soluble back in the day, we defined that as greater than 3 grams being able to dissolve in 100 milliliters of water. But there's stuff that's insoluble where, you know, you would have like a 0.5 gram or a 1/4 gram or 1 gram, and all of those would be considered insoluble. So there's certain ones that are a little bit more insoluble than others. And that's what our Ksp value tells us, is how much of that material is soluble. So when a solid is first added to water, no ions are initially present. As we start to go through, those ions will increase until you establish equilibrium. So solids do not appear in the equilibrium constant. Remember that, right? Okay. So if we're talking about taking a material and breaking it up into its different ions, this is what the equation would look like. The Ksp value would look like this. You're not going to have a denominator because these are your reactants. They're considered your reactants, and they don't show up down in, because it's a solid, it doesn't show up in the Kc, the equilibrium constant. That's what I was looking for. All right, so the AgCl solid does not appear in that equilibrium expression because solids are left out. So the concentration of the solid remains relatively constant. So here are values of different Ksps for different substances. So certain things are much less soluble than other things, like this iron hydroxide here, okay, iron 3 hydroxide. See, that's to the -39. That's really insoluble, versus calcium sulfate, which is insoluble, but not to such a degree. Okay. Bismuth sulfate, look at that guy. That's like crazy. Okay. So if we were to write the Ksp expressions for these following things, what would those things look like? Well, we would have our calcium 2+ times our, what happened to this? Where did this guy come from?
Oh, are you okay? Oh, stop. Oh my gosh, she's having a reaction.
Oh, it's for the next one.
Oh, okay, that should have gotten returned down. Is that right?
Yes.
Oh, yeah, that should be the beginning of this line. No. No, it doesn't. Ay. Where's my notes?
Dude, look, you have to wear like this.
I want to watch you on camera today and also record it.
You want to watch what? What did I say before?
You do it in English, you need to talk to American.
Yeah,
But we can sit
that's what happened. Okay, I need to get rid of this guy here. This should be AG to SO4.
No one else has it.
There. That's what that looks like. Okay, get rid of that guy there. That guy needs to go away. Okay, there we go. All right, so then this would be F minus, and we're going to raise that to the second power. So this would be the expression for that. For this guy, hens. Back in your hen house. Hush. I've got AG 2 plus here. And then I've got my SO4 2 minus here. Oops, that's not right. Hold on. I screwed up. Just hold on. Chill out, chick.
Baby, stop.
Wait, I just
Okay, there we go. Okay. Why does what say what?
I was just saying what Evie was saying.
What, this is wrong?
No, I was just making fun of Evie.
Okay.
You're canceled. You're canceled. Pay attention. You're the one who's making jokes. I'm trying to learn. Sorry, you don't know the chemistry.
All right. Is this making sense here? Why we're squaring that? Because this is a 2 here. All right, then over here, these signs messed up too when it got printed. So they should be right here. That should be your equilibrium.
Why does the other one have to be in the front? Doesn't matter. What?
Evie, please explain. No, she means like
The A.
the AG too.
Because this is your solid and it's breaking down into these things.
Oh, so it does matter. The solid.
Yeah. Because that's your reactant. Okay. And this, I tried to get this to like come out and apparently it didn't work when I printed it. So I apologize.
Probably.
All right. This guy then, I've got my bismuth. It's a +3. I need 2 of them, so I've got to square that. And then my sulfur is a -2, and I need 3 of those. All right, questions? Does that make sense how we set these up before we move on?
Yeah. I think so. Wait, so you just use the first one and the thing?
No.
It actually makes a lot of sense. I'm confused because they didn't I get it, I think.
Okay, do you understand,
Is
Evie?
this all
I
we're
think
doing?
so.
No.
Oh.
Come on, Adam. Did you really think
Yes.
it'd be that easy?
I was hoping. Can't someone hope?
No.
What's next?
Come on. Do you think we should take them?
All right.
No.
So if we've got our PB here, okay, we're going to calculate our KSP value. This we would form X, and this guy we would form 2X, right? Okay. So we are trying to figure out our KSP value. If calculate KSP, if the, okay, never mind. Back the train up here. Hold on. I got ahead of ourselves. They're telling us that our lead concentration here is 1.62 times 10 to the -2. So if this is our lead amount, how much would our chlorine amount be?
Divided by 2. I know.
3.2.
Right, you're going to take this amount because this is 1, and you would have 2 of these formed for every one of these, right? Because this is breaking up. It's breaking up into 1 of these and 2 of these.
What does that X say?
It's a 10.
Okay. All right.
X 10.
Sorry. Oh God, you did. What does that Thank you.
Okay, so for every one of these that breaks up, we're going to end up with 2 CLs and 1 PB, right?
Yeah.
So if we generate this much PB, we have to generate what for this?
2 of it.
Twice as much. So I'm going to remember that my KSP then is going to equal this value times this guy, but twice as much squared.
You have to double it and square it?
Uh-huh.
This is very similar to the stuff we were doing before.
Yes.
Yeah.
That's why it's all in the same unit.
You guys are the ones confused, like.
I'm not confused. Did I ever ask you a question? No.
So when when we take this guy here and we put him into water, okay, a certain amount of him into water, we are going to get this much lead. We would get twice as much as far as our chlorine.
What? Why? Why would it be times it by 2?
Because this guy, remember if we're looking at what this guy, and I'm going to make him into a molecule. I know he's not, he's ions, but I'm going to make him into a molecule, okay? When he's stuck together, we have 2 chlorines for every one of these, okay? So if I have 2 of these, right, let's just take 2 of these, okay? If I have 2 of these, when I split it apart, I'm going to end up with 2 PBs, and I'm going to end up with how many CLs? 4.
Wait, but then how do you, if it says 2 on the other side, why is there 4?
That was just for the example.
Oh.
Why do you have to double it and square it?
How is it doubled if
Normally
there's the
just
same
square it if
amount?
there's 2 individual.
What do you mean?
Okay, so when you have a PVCl and then you split it up, you're gonna have 1 PVCl.
Right?
Okay, and so then you have, so your 1 PV is only gonna have like 1.6, but then you have to double it because you're having 2 CLs instead of 1 PV.
Let me get her to where you're at, and then I'll get you to the next step, okay?
I'm not getting it.
How come PVCl? There's 2 chlorines and 1 PV.
But what's the 3? Where did that even come from?
The
Oh, I
three-
see it on the bottom. It's right there.
It's a 3. You didn't know where the
Times
1.
1.62 by 2 to get the chlorine value.
Because there's 2 chlorines
And then
you're
one
timing
would
them
each.
together.
Oh.
Are you good?
And you gotta make sure that they're equal.
I understand, I think, but I won't know how to do it on my own.
You're good over here.
Okay, so guys, if I had 16 of these, Evie, okay, so let's pretend that I got 16 of these. How many leads would there be in 16 total ones of this? 16. How many chlorines? 32.
Yes, Evie.
That's where we're getting these from.
Oh, wait, but why? What? How did you pick 16?
I picked 16 because this is 1.62 times 10 to the negative 4 or negative 2, so I could get you to kind of see 16 and 32.
Okay, I
Okay.
understand that.
All right.
So, but they'll give you those numbers?
They would have to, yeah, they gave you this number. That's where we got that number from, which we knew to double it to get to here. Okay. All right. Now everybody's on that page. Yes? Okay. So if we wanted to figure out KSP for this, our KSP would equal the concentration of our PB times our CL minus concentration squared. We get that square from right here. This is the concentration for our CL. We figured that out already. This is our concentration for our PB. So we take this and square it. Did that make sense why we square it?
Because there's a 2 in front.
Because it's 2 and 4. But you also double it, right?
Well, you had to, yeah, because they didn't tell you what the value was. It's just like if you had an ice table, you would have X and 2X, and then when you put it into the KSP, you would go X times 2X squared, right? Back when we were doing ice tables. And then that became 4x squared. Remember that? Do you like those little bites that you like fudge stripe cookies? They're not as healthy for you.
I like Samoa. She's talking about fudge cookies. I don't think she wanted us to do this. Just take it.
That's way too much. Okay, so are you with me here as far as this stuff? Okay, all right, so that's how they came up with that value. All right, we have copper bromide here. So that as you're going through, you can check your work.
Is it really gonna affect you that much? You still have to get to it.
Your mom.
No wonder why no one's not gonna come to this game tonight, because four.
I don't know what to pose.
Me.
No. Who are you yelling at, Elle?
All right, so here they're telling us that we have a measured solubility of this for our copper 1 bromide. Okay, so that means that our Cu is going to be 2.0 times 10 to the minus 4, and our bromine is going to be
Oh no.
2.0 times 10 to the minus 4. Okay?
Wait, why would they? Oh, never mind.
Because they're in a 1-to-1 relationship. Okay? So our Ksp then is going to equal these two multiplied together, not raised to any power because there's no coefficients. Essentially, yeah. So you should end up with 4.0 times 10 to the minus 8, which this is a good opportunity to kind of talk about, you know, when you have to square things, right?
Yeah.
How you would do that with exponents and such. This is an easy one to see that with. You'd multiply these guys and then you add your exponents together.
Add 6 and 6, it's not 8.
4.
2 times 2 is 4, and 4 plus 4
Where are you getting
is 8.
6?
It looks like a 7. Oh my god. Stop asking questions. Now I can see why you're a tad bit confused.
All right, it's this 4 here. That's what I tried to write there, there, and there. It's not easy to write down below here and have it show up on a different screen. So I'm trying.
Wait, so when did I get my favorite?
Okay, moving on. We're going to calculate the Ksp value for bismuth sulfide. Solubility is given here. Okay, so we have to take this value for bismuth and for sulfur, and we're going to have to multiply it by the subscripts to be able to get the concentrations in there. Okay, so let's talk about how that looks. So Bi2S3 is solid. We're going to have 2 Bis. All right, to be able to figure out this, we have to do 2 times, because there's 2 of them, times this solubility here, which is 1 times 10 to the negative 15.
Excuse the interruption. Would Joy Forster White?
And here I need
SWS
3 times
Joy Forster
1
White,
times
the
10
SWS
to
office.
the negative 15. So this is 2.
You just multiply the coefficients with the inside, and it's just like you squaring the direction.
Okay. So this ends up being 2 times 10 to the negative 15. And this ends up being 3 times 10 to the negative 15. Then, when we're doing our KSP value, then, are you paying attention over there?
Yes.
I have to take this and square it, and I have to take this and cube it. Were you able to get this value on your calculator?
Let me pull out my calculator. Yep, she wants to make sure you get a calculator below it. Oh, no, I did it wrong. You did it right.
Yay or nay?
Hold on.
I got it.
Yay. 1.8 negative 7/3.
I got 1.08.
Yeah.
That.
2 sig figs, 2 sig figs, 2 sig figs.
2 sig figs. Oops. 2 sig figs. Isn't that 1 sig fig?
Oh, 2.1.
That's 2 sig figs.
That small point makes it 2. So we can only base on like the starting point.
Yep.
So if there's like, if we have one guy that has like 2 sig figs and we have another that has 3.
2 sig figs for your answer. If you're multiplying or dividing. Addition and subtraction rules don't run different.
Rules for those are how?
Different. So if you had like 2.0 plus 5.00, your answer would have to be 7.0.
So just keep the
Smallest number of place values, yeah.
Is this similar, or should I stay? I really do that.
Well, what if it's like 5.0 plus 0.0
Just let me, can I go to the bathroom?
0.20?
0.0020, so that'd be 5.0 would be your answer.
This one, can I go to the bathroom?
Yeah.
Okay, wait for me.
So anything that's past like the place
Smallest, yep. Okay, so then we're talking about sig figs. All right, so now we're going back the other direction. Okay, now we're going to be given KSPs, and we've got to figure out the solubility from that. So this is essentially the reverse of what we were doing before. Okay, so here we have CaCO3 solid. That's going to break apart into Ca2 plus CO3 2 minus. Everybody cool with that? Okay. When this breaks apart, then this is going to be X. You're going to form X, and you're going to form X. We can do an ice table if you want. Want to do an ice table? You can do an ice table. Okay.
What's the difference between this page and the last page?
This page, they're giving us, the last page we were calculating the KSP. Here they're giving us the KSP, and we're trying to figure out these solubilities. So it's essentially the reverse of what we were just doing. So here, before we start out, we don't have any of these things. when we go through this, we're going to form X. We're going to form X. And then at equilibrium, we'll have X of each of these. And it doesn't matter on this side because it's a solid anyway. Get all of it. I'm not going to calculate it in anyway, right?
So are we trying to find the concentration?
We're trying, yep. The solubility of it, yep. Moles per liter, which is concentration. And then they want us to go on and do grams per liter. We can figure that out too. All right. So when we do this, that means that our Ksp is going to equal the Ca2 plus and the CO3 2 minus. Neither one of these gets raised to a power because we don't have any coefficients here. So our Ksp is going to equal, if we substitute in our x's here, x times x, which is x squared. So x squared then will equal our Ksp value, which is 3.8 times 10 to the negative 9. That means that x, if we take the square root of this value, will equal 6.16 times 10 to the minus 5 molar. So that's going to be the concentration when we throw this into water. That's going to be the concentration of each of these things. So not very much of that will end up coming out if we started with a mole.
So 6.16 is what?
Huh? Yep, that's the concentration of the calcium ions that would be present in that sample.
After they're dissolved.
Mm-hmm. And it's going to be the same number of ions for the carbonate because they're in a one-to-one relationship. Okay. So here we have Ksp values here. I think this is going to be your homework this weekend. Is going to be this one and this one. Okay. Questions?
Yeah, how do you do number 4? Because it's a little different. It says it's 7.4. Yeah.
Okay. Yep. No. You're just going to do this one for homework.
Process one out or
No, you're going to do it. We'll do it on Monday.
number 4?
Yeah.
So
You're going to do this one for homework and your lab.
All right.
Okay. So do this one. Do it right now with a partner.
One question.
Do one. Oh, but you have your lab.